So here I'm asked to write down an example to show that each of the following two statements is not correct. And then the first statement here is that the factors of an even number are always even. So we're basically looking for an example that's going to disprove this. We're looking for an even number whose factors are not all even. So the way that I started thinking about this question is if we take an odd number and multiply it by any even number, we're always going to get an even result. Now this kind of statement here is already disproving the fact that the factors of an even number are always even, because if we take any odd number, I'm going to go with 3, and then an even number, which I'll just take as 2 here, then that's going to give us an even result of 6. So we've taken the factors of 6, which is an even number, and its factors are 3 and 2, so one's odd and one's even. So this shows that the factors of an even number are not always even, as there's an odd here. So then, to get the mark, I'm just going to write out that 3 multiplied by 2 is equal to 6. And now I'm looking for an example to disprove the fact that all the digits in odd numbers are odd. Now this one's arguably a little bit easier to go about, and if you think that every other number has to be odd, if we were to start a number with an even number, so if we took a 2-digit number and started it with an even number, such as 2, then there are going to be 2-digit odd numbers that start with a 2. So we've got 21, 23, 25, 27 and 29. So I could just take 23 as an example here. And then we have the 2, which is even, and the 3, which is odd. 23 is going to be an odd number. However, one of its digits is even, so the 2, and one of its digits is odd. So we've just there come up with an example that shows that this is not always correct.